Hey everyone, robotics. It is a fascinating and rapidly evolving field that combines science, engineering, and technology to design, build, and operate robots. These machines, they are not just tools, they are extension of human innovation, capable of performing tasks autonomously or with minimal human intervention. See, robotics spans various domains, including industrial automation, healthcare, space exploration, and even entertainment. My name is Sharath Narendra, and I'm here to take you through your first steps into robotics at ANARC. The beauty of robotics is what makes it truly unique. That is, it ties into various components of engineering and makes the term we know as robotics. So let's move further. These are the contents that I am going to take you through today. Going through these, you will learn to appreciate what we call robotics. Robotics is more than just building machines, it's a multidisciplinary adventure. It brings together diverse fields like mechanical engineering, computer science, which powers the brain of the robot, let me tell you, like artificial intelligence and machine learning. But it doesn't stop there. Electrical engineering ensures power and control systems, mathematics, even biology and biomedical engineering are contributing to robotics. See, through this adventure, we are not just exploring technology, we are exploring fields, integration, and global opportunities. Although you haven't seen the first one, the first part of this introduction to robotics, this video in itself acts as a standalone. So, fight through. Robotics integrates knowledge like healthcare, agriculture, and defense, and space exploration too. It has many global opportunities too. Recently, you may have heard of the term mechatronics if you have gone through JOSA, and we'll be going through that now. Let's talk about two closely related fields that are often confused: mechatronics and robotics. Mechatronics is a multidisciplinary branch of engineering that focuses on integration of mechanical, electrical, and computer systems. Think of it as the foundation that combines these technologies to create smarter machines. For example, an anti-lock braking system in a car is a product of mechatronics. And it uses sensors, control systems, mechanical components to ensure safety. On the other hand, robotics takes this integration to another level. Robotics focuses specifically on creating intelligent machines capable of autonomous or semi-autonomous actions. While mechatronics develops systems that require human input or control, robotics aims for independence and intelligence. A good example is a humanoid robot like Sophia. You may have heard of the term Sophia. If not, Google it and you will have time of your life. Or a self-driving car that can make decisions and adapt to its environment, that comes under robotics too, according to Penn University. The key difference lies in purpose and complexity. Mechatronics is about enhancing and automating existing systems, while robotics is about designing systems with intelligence and autonomy. Here's where the connection comes in. Robotics relies on mechatronics as a core discipline. See on your screen the increase in mechatronics and robotic courses in the market. And that's not just showing until 2024, that's estimate until 2032. But this estimate you're seeing on screen is given before ChatGPT. So you can think there is no limit to robotics. So while mechatronics and robotics are distinct, they are deeply interrelated too. The thing that is flashing on your screen right now is a self-balancing bot. The beauty of this bot is that it has no limitations. Everything that you are gonna learn in this YouTube series of ANARC will be integrated in this bot. See, right from motors, sensors to PID control. Self-balancing bots are a remarkable innovation, showcasing the principles of balance, control systems, and real-time feedback. They're not just engineering marvels, but also practical tools used in applications like personal transportations, as seen in segways and robotic assistants in narrow or uneven spaces. That is an EvoBot that is specifically designed to help people in cargo sites. And this is Kim E. This has been designed by Kronos Robotics to help people who are Paralympic. And both these bots have one thing in common. They are based on their fundamentals on self-balancing bot. So let's move on from self-balancing bot into fields of robotics. First up, we have industrial robotics. Industrial robotics, robots used in manufacturing and assembly lines are example of industrial robotics. And to give an example, robotic arm, you may have heard of the term robotic arm. It can be seen on screen. That is an example of industrial robotics. Then we have medical robotics, Da Vinci surgical system. That is an example of medical robotics. Service robotics, you may have seen cleaning bots, right? Like vacuum cleaning bots. These are example of service robotics. Then we have military robotics, like unmanned ground vehicles, unmanned aerial vehicles. These are some examples of military robotics. Then we have humanoid robotics. You may have heard of Sophia, right? Sophia is a humanoid robot. And then we have space robotics, Mars rovers. Mars rovers can like go through extreme environment conditions where sustainability of human life is a bit of a question. So there we have help of robotics. Then we have agricultural robotics. Robotics can be used in farming to automate certain tasks like planting, looking over the crops, or even plucking fruits and detecting soil health. That is done using AI, robotics, and sensors. That is a beautiful scope. But the thing about fields in robotics is you are the limit. These industries are the present industries in robotics. If you think of any task that can be automated, it is in robotics. Robots are used in entertainment industry too, like animatronics. Animatronics are majorly used in Jurassic Park, Jurassic World, these kind of films. So I think animatronics. So that is one field you can explore. Robotics is an incredibly diverse and multidisciplinary field. With several specialized areas contributing to its growth, let's take a look at some of the key fields. First, we have mechanical robotics, which focuses on designing the structure and movement of robots, like creating arms, joints, or say wheels, legs, to perform tasks like anything like lifting, walking, flying. This come under the mechanical part of the robotics. Then for electrical engineering, electronics engineering, this is very crucial because this is what that powers the machines, like equips them with sensors to perceive the environment, detect obstacles, or like microcontroller, microprocessor that acts as a brain in certain way. Then we have computer science and artificial intelligence. This is what that gives intelligence to robot, like ability to make decisions, solve problems, and adapt, allowing for tasks like autonomous driving and drone navigation. Then control systems, which ensures precision and accuracy. Then we have biomedical robotics, like human anatomy. Knowing human anatomy is important to create prosthetics, right? Exoskeletons also. So there comes biomedical engineering. Then we have chemical engineering also to certain extent, like energy manipulation and you can say efficiency, that comes under chemical engineering. Then we have like cognitive robotics, that focuses on enabling robots to mimic human behaviors such as reasoning, language processing, or even emotional interaction. What is fascinating is how these fields often overlap though. Like for example, creating a humanoid robot requires expertise in mechanical design, AI, sensors, and control systems. This interconnected nature makes robotics such a dynamic and impactful discipline that shapes future of technology and innovation globally. You may have heard of the term like jack of all trades, right? Robotics is exactly that. Next up, we have global opportunities in robotics. See, the thing about opportunities is they are not limited, right? By the time I upload this video, there may have been a new opportunity coming up. So these are some that came into my mind when I'm editing this video, like research and development, entrepreneurship. Entrepreneurship reminds me there's a company called Boston Dynamics. If you don't know, please check them out. They make really good robots. And then we have education and careers, like AI specialist, AI engineering, robotics engineer. These things come under education and careers. There are various industries that you can work while coming to robotics too, right? It's a multidisciplinary field, like I telling you, like I keep telling you. So there is no limitation to robotics. By an estimate, by 2030, the robotics market is expected to exceed $200 billion, And if you add AI to this market, then I think there is no boundaries to the expected market share. So it's only up to you what you want to pursue. But robotics is like a jack of all trades, like I keep telling. There is this quote like jack of all trades is master of none, but that's only half the quote. What is the full quote? If you know, comment it below. And the sub to the channel will be robustic. Sorry, I got a dry sense of humor. And moving on, let's end with a quote. The people who are crazy enough to think they can change the world are the ones who do. This is a quote given in the Apple's Think Different campaign, and I think it resonates very well with everyone. I mean, most. It resonates well with me, and if it resonates well with you too, please share this video and subscribe to this channel. Thank you. Signing off, Kuppala Sarath Narendra.